Good evening, welcome to our next lesson on centroids. There we have a section. You can see it looks like sort of a letter Z, and that would loosely be called a Z section. Okay, whether it's steel or concrete, we call that a Z section. People, now we need to find its position of centroid about a particular point A. I am going to hang on a sec. I'm going to make point A. Now, can I give you some advice? If I don't give you a point A or whatever point to work from, always choose the most extreme point. You can choose that point, you can choose that point, you can choose that point. Don't do it. Okay, so either choose that one there or that one there. I'm going to choose that one over there. Okay, that one there. So there's our point A. Okay, what's the next thing we do is we divide the section up into sections that we know, either squares, rectangles, semicircles or triangles, like we know from the sheet I gave you. Okay, right, so let me just choose a nice color here. Right, so I'm going to divide it like that, and I'm going to divide this like so. So of course it's way, its center is sitting over there, its center is sitting over there, and sitting over there. So that's element 1, element 2, element 3. Okay. Right, I'm not going to draw in the x and y axis. Something people didn't mention in the previous one. The x and y axes of each element is in small letters, and I don't even remember the big x and y axis for the whole section was big X, small, and big Y. Okay, so small letters is for the axes of the elements, and the capitals are the axis of the big section. Okay, notice that, do it like that, copy that, otherwise you will confuse yourself. Okay, right, this is it's element 1, element 2, element 3. Okay, area A. Right, so what's the dimensions for element 1? It's 160 times 40, so it's 160. Oh, by the way, I didn't mention, some people like to do it in tables, and some people like to do it the way I showed you previously. You can choose what you want to do, but know what you're doing. I find that when a lot of people use tables, they say, if I take that block and I multiply by this block and I add it, I get, then they tend to not understand what they're doing. You must understand what you're doing. Then it doesn't matter whether you're using tables or the way I did it previously. But I'm doing it with tables now, because some people like tables. I don't know why, but there you go. So the dimensions for element 1 is 160 times 40. So it's going to be 6,400. Right. And what is y? What is y for this element here? It's distance from the centroid of the element all the way up to there, and that's 20 years. And what's a times y? A times y is 20 times 6,400. So that will be 12, 8. I'm going to do all the y's first. Element number 2. It is 20 times. Now people, be very careful. Be careful. Okay? Oh, I didn't give it that, did I? Silly me. Okay. So let me just say, from there, to there is, let's say it's 600. Sorry, man. where 600. So of course, element number 2 is 26, but it's not 600 high. How high is it? It's 600 minus 40 minus 40. So 600 minus 80. So it is 520. Okay. 600 minus 80 is 520. So the dimensions for element 2 is 20 times 520. Right, let me try the work out. 20 times 520 is equal to 10,400. Why? What's y? Y is the distance from the centroid all the way up to where A is sitting. And what's A equal to? A is equal to 520 over 2 plus 40. Did you get that? Y for element number 2 is equal to 520 over 2 plus the 40. 520 divided by 2 is equal to, plus the 40 is equal to 300. If you're just writing it down, you're not learning anything. And of course, this is A times Y. So it's 300 times 10,400 is element number 3. What is dimensions? 200 times 40. That's a nice easy one. It's 8. 1, 2, it's 8,000. What's Y? Are you watching? Y is the distance from the centroid of the element all the way up to there. You can either say it's 600 minus 20, which is 580, or you can say it is 20 plus 520 plus 40. You must get the same answer. Okay, so I'm going to say Y is 600 minus 20, so it's 580. And 580 times 8,000 is equal to 4,640. 4,640. Here we go. Right. So we're done with all vertical distances. Let's do the same for the horizontals. Right. The area A stays the same. What's x? Element 1. X is the distance from the centroid to point A over there. Okay, maybe I must change this color. Okay. And make that like so rather. Okay. So x is the distance from the centroid to that line over there. And how far is it? 160 over 2, so it's 80. What's AX? AX is 6,400 times 80. So it's 80 times 6,400 is equal to 512. Right, element number 2. What's x? Are you watching? X is the distance all the way from there, all the way up to where x is. And how much is it? It's 160 minus 10. So 160 minus 10, 150. What's AX? 150 times 8, so it's 150 multiplied by 10,400 is equal to, so it is 1. There we go. The last one. What's x for element number 3? Is the distance all the way from there, all the way up to there. If I draw a line there, that will be that line going down there. So how far is it from there to there? Okay, it is from there to there is 100, and from there to there is 160. From here to here is 100, and from there to there is 160 minus 20, so it's plus 140. and it is 240. There we go. AX is 240 times that over there, so it's 240 multiplied by 8,000. Just that over there. Let me just check something. 165 times. There we go. So people there, we've summed all. Right, and bar y is equal to, maybe I should just change it quickly there. Bar y, that's the formula. It's the sum of ay over the total area, or the total area. Alright. Now before we can do this, we need to sum them up. And we're going to sum them up all over here. Okay. We sum all of those, we sum all of those, we sum all of those, we can work it out, and the job's done. Okay. So the total area of the section, I'm going to add it all together first. So I'm going to pause there just for a moment while we all work it out. Okay people, I'm back. Alright, I've totaled them up. Total cross-sectional area, total sum of the AYs, total sum of the AXs, because that's what our formula requires. Here's the formula. So the sum of this here is that over there. So it is 7 over the total area, which is that over there. So 7888, 1, 2, 3. Okay. Let's check my answers. 0.06 millimeters. It's the distance. If you leave out millimeters, I take over mark. Okay, it's the distance. Right, and bar y is equal to the sum of AX over the total cross-sectional area of the section. And AX is that over there, all of those 3,992,000 over the total area. Those 3,992 160.97. I get it looks like reasonable ounces, and it's millimeters. If you don't put the millimeters in, take over mark. Okay, so if you don't put that in, like 2 marks minus 2 marks. Right people, but what, I'm asking the question, what does it mean? It means this. Right, let's see, so bar y is the distance bar y is the distance from A down. Notice down. Why is it down? Because we worked about that point there. Okay. Oh, should have done that. Okay, and x is the distance to the y-axis, and it is 160.97. It's just sitting over there. You don't need to draw this in on your sketch when you do it, but I'm just telling you what it is, because some people never understand, they work it out, and I say, what is it? Sir, I don't know. Well, this what it is. Okay, what's bar y? Bar y is the distance from point A all the way down to there. That's bar y there. And what's bar x? Bar x is the distance from that point there all the way down to that over there. Okay. Now why is it going that in this way? Because we worked about point A, so that means it's bar y is the vertical distance. Are you tuning in? bar y is the vertical distance from the point we work down to the horizontal x axis. Notice the capital letters. And bar x is the horizontal distance from the point we work about left towards the vertical y axis. Notice the caps. So the x's are small letters and the capital numbers are the big letters. Okay. So people there. So now we know how far this way the y axis is. Now we know how far down the x axis is, and of course the intersection of those two axes is the centroid for the whole cross section. And we've answered the question. Question just determine the centroid. That's the centroid of that. Okay. Okay people, that's all for now, and I'll see you in the next lesson.